In the next series of classes, we will discuss descriptive statistics, or the tools we use to describe distributions. In Section 1, this class, we will focus on scales of measures and frequency distribution. Variables can be measured in many different ways using different types of scales. Knowing the scale of measure will be very important for us in order to interpret the scores on the variable and in order to choose the appropriate statistical method to evaluate the results. In a nominal scale, objects are scored on categories that differ in kind or name. So there's no numerical relationship between categories on a scale. They differ in name. If we were using a nominal scale to measure depression, we might ask test takers, "Are you depressed?" and then ask them to respond yes or no. Examples of other nominal scales might be, "Are you a smoker?" yes or no. Or, "What is your political affiliation? Are you Republican, Democrat, or Independent?" When we use an ordinal scale, objects are scored on categories that differ in rank. The old Sears catalog used to rate its products as good, better, best, which is an example of rankings or an ordinal scale of measure. In an ordinal scale, there's no assumption that there are equal spacing between points on a scale. So we don't assume that there's the same distance between Sears products, between good and better, and between better and best. One of the best examples of an ordinal scale is a Likert type scale. So for example, if we were measuring depression using a Likert scale, we might ask the individual to respond to the following statement: "I am depressed," by asking them if they strongly agree, disagree, or strongly disagree with the statement. When we use an interval scale of measure, objects receive a score using a scale with equal intervals between points on the scale. Although there is equal spacing between points, there is no true zero point on an interval scale. The interval scale will be commonly used to measure the abstract constructs that dominate our field, like introversion, self-esteem. So we might devise a measure of depression comprised by many items about individuals' moods, and the total score of which would have equal spacing between all points. That would be an interval scale. Examples of interval scales include the full-scale IQ scores from the WAIS 3 and the Fahrenheit and Celsius temperature scales. In psychology, we will assume that many of our tests are interval in nature. We will make this assumption although individual items on a test are ordinal in nature. The scores from these items will ultimately be added to a total score, what we call a summative scale. And we will then assume that the total score on the test is interval in nature, even if the individual items were not. A good example is the Beck depression inventory, the items of which are clearly ordinal. However, the total scores are generally regarded as an interval scale. Although scores on the interval scale are equally spaced, there is no true zero point, as I mentioned. There may be a zero, as there is on any measure of temperature, but the zero does not correspond to a physical reality we would describe as no temperature, or the absence of temperature. Similarly, there may be a 0 point on a measure of intelligence, but it would not correspond to a reality in nature we would recognize as the absence of intelligence. In a ratio scale, objects receive a score using a scale with equal spacing between points and with a true 0 point. Because there is a true 0 point, ratio statements will be possible with a ratio scale. For example, we'll say one score is 3 times greater than another score. We might measure depression using a ratio scale by counting the days of the week an individual experienced suicidal ideation. Examples of ratio scales include time, weight, height, and money. Scales of measure vary in sophistication. Nominal scales are least sophisticated. Ratio scales are most sophisticated. Scales that provide the maximum amount of information about individual differences on the attribute in question are considered most sophisticated. So we could measure political attitudes, for example, by asking someone if they were conservative or liberal. This would be a nominal scale, would be the least sophisticated way to measure the phenomenon. Or we could measure political attitudes by scoring someone on a scale that ranges from 0 to 100, in which low scores indicate liberalism and high scores indicate conservatism. This would be an interval scale, and it would be said to be more sophisticated because we're able to make finer distinctions or differences between people in political attitudes. A frequency distribution reports the number of individuals or test takers scoring at a particular value. Remember, an individual can receive either a score on a continuous variable or be classified on a categorical variable. When a variable is measured using a continuous scale, individuals will receive scores. For example, on a measure of anxiety using an interval scale of measure, we might use a frequency distribution to report that 4 people received a score of 10 and 6 received a score of 11. When a variable is measured using a nominal scale, the frequency distribution reports how many individuals fell in the categories of the scale. So, for example, a frequency distribution might report that 25 individuals were counted as Republican and 33 were counted as Democrat. In the next few slides, you will be presented with examples of common ways graphs and tables are used to present frequency distributions. A few words about the slides we are about to see. The data are from a survey in 1995 of cultural, health, and economic indicators for countries throughout the world. The data are from the core data available to purchasers of SPSS, a statistical package. The first example here is of a bar graph. And this presents the number of objects scoring at each category for a test that is measured using a nominal scale. Note, predominant religion is a variable that is measured using a nominal scale. In this type of graph, the bars do not touch each other, as if to demonstrate that the levels of the scale do not have a numerical relationship to each other. A histogram is just like a bar graph, except it is used to report the number of objects scoring at each point on a measure that is using an ordinal scale or greater. Notice that the bars in a histogram touch each other, indicating a numerical relationship or a ranking relationship between positions on the graph. A frequency polygon is a line graph that connects midpoints of class intervals for each interval of a histogram. So this type of graph may tell us how many individuals scored between 12 and 20, and how many scored from 24 to 32, and so on. Another type of graph is the box and whisker. The box and whisker draws a line at the median, which is the center line within the box, and the box stretches from the 25th percentile to the 75th percentile. Thus, 50% of the distribution falls within the box. The whisker stretches from the box to the upper and lower 10th percentile, what we will call a decile, but the whisker can be no longer than 1.5 times the length of the box. Data points that fall beyond the whiskers are identified as outliers. This type of graph is used frequently in statistical analysis because it reveals the shape of the distribution and indicates the extent to which the data contain outlier or extreme scores. Looking at the data in this example, for Catholic countries, the median, the center line, corresponds to a score of approximately 60%. And the semi-interquartile range, or the middle 50% of the distribution, ranges from approximately 45% to approximately 75%. There were no outliers in this data. If there had been, there would be notes on the graph beyond the whiskers for each of the cases that was an outlier. Before going to the next slide, see if you can identify the two scores between which 80% of the objects score for the Protestant countries. It appears to me that the lower whisker corresponds to approximately 40%, and the upper whisker extends to approximately 90%. Remember, the whiskers spread to the upper and lower decile, beyond which 10% of the objects scored in either direction, unless to do so would mean that the whisker would stretch beyond 1.5 times the size of the box. So the whisker will spread no farther than that threshold. I don't have an example of the next table that we're going to look at, and that's a cumulative frequency distribution table. As indicated in previous slides, a frequency distribution reports the number of objects scoring at each point on a scale. A cumulative frequency distribution table is usually combined with a frequency distribution and reports the total number of objects and their percentages that scored at every point on the scale and below. So a cumulative frequency distribution will build until all scores are accounted for, and the cumulative frequency distribution percent is equal to 100%. A frequency distribution and a cumulative frequency distribution can be used with any scale of measure. Another type of table frequently used in statistics to account for the frequency of a distribution is a stem and leaf graph. This reports the number of participants scoring at every point by creating a larger score unit in the left, which is called the stem of the graph, and then repeating the last unit of the score for as many people who received that score over in the leaf section of the table. In the sample you have here on this page, data are the percentage of people living in cities for nations with Catholicism as the predominant religion. The graph tells us that one country had 5% of their citizens living in cities. One country had 11% living in cities, and two countries had 44% of their population in cities. Notice that each number in the leaf represents one case, and we can count up the number of leaves that are alike for each stem to determine the frequency of test takers at every score. Thus, two countries had 70% of their population living in cities in this frequency distribution. Before going to the next slide, see if you can answer what was the most frequently occurring score, or the mode, of this distribution. The answer is 73%. There were 4 predominantly Catholic countries in which the percentage of the population living in cities was 73. This is indicated by the 4 threes that are in the leaf associated with the stem of 7.